Welcome to this webinar from Axians and Netskope. Out with the old, in with the new. This is about managing the challenges of remote working. So my name is Chris Gilmore. I'm the CTO for Axians in UK, and today I'll be going through this webinar with my colleague Ross Thompson from Netskope. If you'd like to say hello.
Yeah, hi all, Ross Thompson. Yeah, Netskope. I've been with Netskope for, gosh, pushing 3 years now. My history sort of basically out of college for the last sort of 15, 16 years has been cyber. I've worked for a number of companies like Bluecoat Systems, Symantec, and now Netskope. And yeah, look forward to running you through a bit of a talk on zero trust network access, private access, where the enterprises are going today, and how Netskope deliver on sort of a lot of customer asks we're seeing today around zero trust.
Perfect, thank you. So I think, oh blimey, we've got a flurry. So this is driven really by the kind of market trends. If you look at, if you do Google searches, ZTNA is a massively focused area for a lot of businesses. And this is realistically as a kind of response to the fact that a lot of people were caught short with COVID. They had something in place, but it wasn't quite 100%. A lot of people had a lot of sticking plaster and chewing gum solutions at the time, and are now trying to find a really robust way to fix that existing problem of VPN. I mean, the VPN's been around for a long time. However, the market, the way we use applications, the way we host things have all evolved and changed, and so the market has moved on a lot in terms of how we access and how we work with solutions. And the idea is to try and isolate or insulate you from the kind of challenges that were experienced during COVID. Move forward a couple of years, and we're now into a model whereby we call it work from Rome, but basically it's a hybrid working, which is now the norm for many people. I don't know about your own individual businesses, but at Axians, certainly there's definitely a model whereby you'll see people 2-3 days a week in the office, and then the rest of the time they're working out at a customer site or at home or out. So really this is about acknowledging the fact that generally 100% of your employees are not in your offices at the same time. People are in Costa Coffees or hotels or airports or customer sites, and they need a secure and reliable way of connecting to the applications that you work with. So this is about looking at the next generation of solution for this, and I think that's a perfect time to hand to Ross to go into this in a little bit more detail. Ross.
Cheers, Chris. Thank you. Right, so I think before I start talking about sort of Netskope technology and sort of features, capabilities, products, it's probably worth understanding a little bit more about zero trust and those zero trust principles. So you'll hear that kind of, you know, in the market, you'll hear about zero trust a lot, and then there are products that address zero trust. So just talking about zero trust principles initially, what you'll primarily hear is really the difference between implicit trust and explicit trust. Technologies without zero trust are effectively implementing an implicit trust, whereas technologies with zero trust are implementing an explicit trust. So we'll talk a little bit more about what that looks like. Great example of implicit trust. I actually went to the cinema fairly recently with my 3 children, and we stood at the ticket stand to buy our tickets. And this is a little bit like when you first try and connect to your VPN and you try and gain access. You know, you need a ticket, you need to authenticate yourself, you need to authorize connectivity and to authorize yourself into the cinema. So we went, I've got children, we went to go and watch this film, Matilda, a great film, if you haven't seen it, by the way. Once we were in, we passed our tickets over, I realized that actually in screen 1, they were showing another film called Scream, which probably wouldn't be relevant to my children, but there was really nothing stopping us from roaming around and going in, looking and watching another film. So people exploit this in the real world. People go to the cinema and they theatre hop, they buy a ticket, they go in and they jump around different cinema screens. So people will always exploit that implicit trust where available. And in the cyber world, we would call that lateral movement or insider threat. Compare that to explicit trust. We think about going to get on an aeroplane, we're going to go abroad. Well, we know that we can't just turn up at the airport, show our passport, and then just aeroplane hop. You can't just go and jump on another airplane. There are a number of checks that we have to go through. We do check-in, there's hand luggage inspection, body scanners, passport control, departure gates, baggage checks, and then a final boarding pass check as well. And so in kind of technology world, that could be things like turning up and authenticating yourself into the airport, applying some kind of device classification. What device am I coming from? Applying specific application controls, content inspection, access policies, access logging, and even re-authenticating that user. Just because you turned up and you showed your passport when you turned up in the first gate doesn't mean that when you get to the last gate that you can just go through. You often have to show our passports multiple times through that whole process. And that's really what explicit trust is. And that's really implementing an explicit trust principle. So we understand the principle of zero trust, but how do we apply that to a product? And that's where you start hearing about zero trust network access. And this is becoming quite consistent across the industry. Chris mentioned you can kind of Google this stuff and you'll find all sorts of articles about zero trust replacing VPNs, 7 alternatives for VPNs, VPN vulnerabilities and exploits, and what does that really mean for your organization, how businesses are replacing VPNs with zero trust network access, and so on. And the reason that's become such a hot topic is because of these, well, primarily these kind of top 4 use cases. And that could be just that lack of visibility. Again, when a user connects to a VPN, working from home, working from a hotel, working from a coffee shop, they have that full visible access to the network. Sometimes that relates to poor user experience as well. So you think about a user connecting to a VPN into your data center. Well, not all the applications might be in that data center today. They might be IaaS hosted, they might be hosted in the cloud. They might be hosted in other data centers. So we're all coming into a central point before then actually connecting back out again to where those applications reside. Sometimes that translates to a poorer user experience. And often these VPNs, they're not there to kind of optimize that traffic. You can connect and there's no optimization. Those security risks we were talking about again. So just having a VPN concentrator exposed to the internet, those are potential vulnerabilities there. We're kind of inviting people into the network. There's a VPN concentrator on the DMZ that has the firewall ports open to allow VPN connections in, but it also allows potentially attackers in as well. And then that kind of cost and complexity, talking about, again, that routing, it's kind of can be quite complex when applications are living in different locations. And also a customer I'm talking to at the moment, they're very driven by mergers and acquisitions. And when they go and acquire companies, they have to kind of envelop an existing VPN solution, another different concentrator, another data center, and we kind of simplify and consolidate M&A as well. So what we hear from our customers, again, it kind of reducing that complexity, reducing that kind of hardware-centric network security, consolidation of vendors. So Netskope, we're not just a zero trust network access product. We can also be a web proxy. We can provide access and control and visibility and zero trust principles across web access as well. So accessing just the general internet, URL filtering, data protection, DLP threat protection, user event-based analytics. We do CASB API, we do endpoint DLP, we do email SMTP. So we can consolidate multiple products into one platform. Zero trust network access is just one capability of our platform. Again, as Chris mentioned, supporting that. I've never heard that before, Chris, work from home. I like that. So supporting that hybrid working, evolving that legacy VPN, adopting those zero trust principles, shrinking that attack surface, and also, as I mentioned before, not backhauling everything to the data center, allowing those users to effectively go directly to those applications, whether they're cloud hosted, data center hosted in the edge environment, wherever it is, a more direct connection to those applications. So just quick comparison on VPN versus zero trust network access. So with VPNs, typically it's a connect first. So you establish a connection to the concentrator into the network, and then you kind of authenticate yourself. So it's connect first, authenticate later. Coarse access, so just kind of that full lateral movement. Typically, once you're in the VPN, you actually become a network resource. That means that you obviously have those open ports visible on the firewall, as I mentioned before, to the concentrator, and you're virtually placed in the network as a resource. So you become a resource in the network with an IP address. So services can access you, you can access services, and there's kind of a full lateral movement across that environment. Whereas zero trust network access and applying those zero trust principles, we want to authenticate the user first before they can actually establish a connection into the environment. We can provide that granular access to specific applications. So if you're in HR, you really only need access to these HR apps. If you're a developer, you only really need access to these developer apps and so on. It's that kind of inside out connectivity and a shield to those assets. So rather than users connecting into a concentrator, if you think about what we deploy within the environment to replace a concentrator, what that actually does is it creates an outbound connection to Netskope. Users create an outbound connection to Netskope, and we stitch that connection together using zero trust principles. I'll show a diagram of what that looks like as we progress. And again, connecting users to specific resources. So kind of across the band, that's providing, we're still providing remote access. We're providing application and network access as well. We're fully encrypting that connectivity from the user to those applications. And again, it's authorized users only. So there are a number of advantages to deploying a zero trust principle across network access or zero trust network access. There's some limitations as well, and we should probably talk about what those are. So as I mentioned, we deploy what's called a publisher in our infrastructure or in our data center. And again, this allows you to kind of scale and create that direct connectivity as well. So if you think about what a VPN does, typically you create a VPN concentrator in a data center. Everyone comes into that data center and then out to the various different places the applications reside. But whereas what we're doing is we're deploying publishers in every location where applications reside, whether they be in data centers or whether they live in infrastructure as a service. Those publishers, you're completely firewalled, so no inbound access required, like you do with a VPN concentrator. The publisher actually creates an outbound connection to our zero trust cloud, our ZTNA broker. The clients have the end user devices have a client installed. They create an outbound connection, and this is what stitches the connection from the user to the specific application. But there are some limitations here. So when it comes to deploying zero trust network access, this isn't like a Netskope limitation. You'll see this limitation practically across the board. Not all applications are ZTNA compatible. So I mentioned before with a VPN, when you connect to the VPN, you become a resource in that network. You get an IP in that network. So those servers and applications in the network can see you as a resource as well. With ZTNA, you don't become a resource in the network. The client can create a connection to a resource, but a resource cannot create a connection back to the client. So ZTNA fully supports what we call client-initiated connections to your resource, but it doesn't support server-initiated connections, so from your resource back to the client. And that will create some limitations around, again, server-initiated traffic, and also things like sort of soft phones on clients as well. If you have on-prem voice over IP, then zero trust network access isn't going to be something you would fully replace your VPN with. You would still require, if you were just going down a ZTNA process, you may still require some VPN because of server-initiated connections and voice over IP. And so with that in mind, that is typically the top challenge for organizations in actually deploying ZTNA. We work with customers who 100%, they just have clients that initiate connections to servers, and they're absolutely fine with that. But then we do have some enterprise customers who have that use case around server-initiated connections or voice over IP, and that becomes a limitation for them in fully replacing their VPN. So typically when we talk about ZTNA, we don't talk about a full replacement when it comes to ZTNA. It's more about an alternative, an augmentation of VPN. And so that's where ZTNA Next comes in. Netskope's invested in a full SD-WAN solution that allows organizations to implement Netskope SD-WAN And with that, we can now be a full VPN replacement as well. So we talked about ZTNA from a zero trust network access perspective. And again, what that would look like is you have these client initiated applications. And this is in most organizations, that's going to be 95 to 100% of your use cases. A client needs access to a data center resource. That could be anything from Active Directory to some web server to an RDP server, an FTP, an SSH server, right? And again, those app gateways establish that connection to our cloud, client establish the connection to the cloud, and then they can route through this with a zero trust principle into those applications. Anywhere between kind of 0 and 5% of organizations will have some sort of server initiated connection as well. And that could be things like soft phones or server initiated connections. And that's where our client can also be used to connect into that SD-WAN fabric, so that you actually become a resource in the network to those specific resources. So we can connect from a fully server and client initiated connectivity perspective into that kind of SD-WAN fabric as well. One thing that's not shown in this diagram is our client also steers connectivity through our cloud service for web access as well. Again, talking about accessing websites, cloud applications, shadow IT, DLP, threat protection, being that kind of real-time inline web proxy as well. So again, we're not just a zero trust network access product. Our client can address multiple challenges around access to the internet and private applications. So using ZTNA, these kind of use cases, and using ZTNA next, either a VPN augmentation or sort of addition to your VPN, or a full VPN replacement supported by ZTNA next, that full hybrid working, supporting that shift to cloud as well. As I mentioned before, rather than bring it all into the data center and then spreading out to cloud, we can put publishers in those infrastructure as a service, so AWS, GCP, Azure, allow those users connect to those applications where they're actually hosted, improving that user experience and performance. I mentioned mergers and acquisitions already. We actually work with customers as well in terms of shipping devices out to users. Brand new devices, they need to be pre-configured. And when they open up their laptop, that laptop already has connectivity into your Active Directory environment, whether that be on-prem or Azure Active Directory. Just by having the client installed on that pre-config there, that device can be provisioned so that the user can start working, immediately after that device has been shipped. And we also support campus ZTNA as well. So if you're actually physically in your environment already, and you're actually sitting at campus and you've got direct connectivity, whether that be through MPLS or public internet, but you've got connectivity into that data center, we can still connect them from the campus as well. And again, those additional use cases around ZTNA next is that server initiated connectivity and providing that comprehensive full VPN replacement. Another overlap that we see, not just in the differences sort of technically between VPNs and zero trust network access, are the things that the security team want versus the infrastructure team. And this has to be oftentimes a converged project where security is saying that they want to improve their security posture, reduce the attack surface, gain that real-time visibility into what applications are being accessed by who, eliminating split tunnels, and being able to do all of this through one console. Whereas the infrastructure team care more about still being able to support those legacy applications, improving the user experience, reducing the complexity of the network, eliminating physical hardware, accelerating their cloud journey, and again, gaining that real-time visibility into who's going where, who's accessing what. So I will move to a demo. How am I for time, Chris?
You're doing well. You're doing well. You can tell it's not me talking because I would have overrun by 10 minutes, but you're doing very well, thank you.
No, that's great. Excellent. So let me jump out here. Oh, my session has timed out. Let me log back in here. Bear with me 1 moment.
Right. So whilst Ross is trying to get that back online, I think, you know, the last slide kind of captures quite a lot of this, in that there's always a kind of confliction in terms of the variety of teams that are involved in working with users across infrastructure and security. And one of the things that the ZTNA gives you is the ability to have a consistent approach. So whether you're in the office or you're in petrol station, hotel, whatever, and the work from Rome spectrum, working from home, you know, there's consistency in how the security policies are applied to you, which gives them more predictability from the kind of CISO's perspective, and it makes it easier for people to then operate a kind of a secure infrastructure from an operations perspective.
Cheers, Chris. I'm obviously not sharing my machine properly because you're probably just looking at Spock right now.
We're looking at a very good Spock icon, yes.
Bear with me. Let me jump back here. Oh, I don't want to do this one. Bear with, sorry. But let me reshare my correct screen now. Oh, that's odd. Why are you not seeing my? Okay, let me do something different. Then you should be seeing my entire screen, not just my desktop. But jump over and
Apologies, folks. This is the first time we've used Teams for a webinar, so there's we're learning as we're going here. So apologies for a few teething issues.
Let me start here, and I'm going to have to jump into a different sharing in a moment. But yeah, so in terms of the Netskope platform, what I've done is I've gone ahead and defined some specific applications within our app policy. So if we go to private applications, effectively what I've done is I've defined all of my various different applications, and we can do this by specific application. So we can do it based on its IP address, or we can do it by a fully qualified or partial domain name. So sometimes organizations don't know, you know, what is it that I should be, what application should I actually be publishing? I have no idea. I could have 100 different applications. And so what we have is we have something called app discovery up here. So oftentimes when we work with customers, we'll turn on app discovery. We'll let that run for a week or so, and that will help us identify exactly the applications that are being consumed within our organization. And then we can start to understand a little bit more about which applications should users be accessing and be a little bit more granular. But even if we don't want to provide access down to the specific IP address, we can still use things like wildcards, star.domain.com or something like that to provide a wider access. And as we grow and as we learn, we can start to bring in more control over the more granular applications. But what you'll see is that, for example, I have a NAS drive here, so a file share service, which has a particular IP address, and that is actually hosted in my lab environment at home. But I also have a few applications over here as well. So I have a domain controller, for example, that also resides in AWS. And you'll notice that they sit on completely different networks. So I've got a NAS drive that's on a 192.168 network, and I've got a domain controller that's on a 172.31 network. And that's just because this is my, effectively, this is my my on-premise domain Active Directory domain, and this is my my cloud service. And so with that, I can now start to define a policy about who can actually gain access to those applications. And so within my real-time policies, and you'll see actually in here, there's a mix of things. I've actually got some policy that's blocking access to gambling and adult websites and online ads. And this is just my standard secure web gateway. Again, not really in scope for today's conversation, but all part of the platform and my real-time policies. If I scroll down, I have some policies here around private application access. So we can come in here and we can have a look at, for example, this NAS drive. Who can gain access to that? So who is my users that can gain access? Well, at the moment, I've got all users, but I could define specific users. I can define how they're going to access it using our client. And then I've got the application. I've got an allow in there. So really just breaking that down to the specific users from a policy perspective. Let me just jump into another share now, another screen here. So let me share this screen here. And from a user's perspective, we have our Netskope client installed down here. And so what they'll be able to do is we'll go in and let me just see if I can actually connect here. So we've connected successfully to 172 network. This is our cloud service. And without having to kind of switch networks or switch VPNs, we can also go and connect into our 192.168 network as well. And these are, you know, you've seen a kind of connecting to the data center via 192.168 and a NAS drive. And you've also seen, like, for example, a remote desktop connection to, in this case, the domain controller in AWS, different network. But again, the user can just kind of work seamlessly and access applications no matter where they reside. And that's all steered through that one Netskope client. They've had also the policy applied, so we can't just go and access other applications that we're not within a policy for. Let me go and share again back to the Netskope platform. Where's my browser? So
if anyone has any questions, by the way, there's a Q&A function in the top bar. Please do post them in there, and then we'll see if we can answer those towards the end of it. But please do add into this. Thank you.
So before I get into that, actually, let's go and have a look. As users access resources, we record all of that under our network events here. So we can already see, let me put in some filters here because I have a lot of network events going on. Let's pick on a particular user. I'll pick on a couple. Let's go him and let's get, let's see if we've got anything here. So again, so we've got our user here. Let me get the NAS application up. There we go. So we can now see, for example, this particular user on this particular date and time accessed that application on port 445, which is your sort of SMB or NAS sort of ports. It was a private application. He matched an allow policy, how much data he actually transferred in that session. We can hit that magnifying glass. We can understand a little bit more context about that. So we can see who the user was. He was on a Windows device. We can see the host name of his machine. We can see the operating version that he was operating, OS version, the destination IP, the destination port, operated over TCP kind of versus UDP. It was a data center application because he connected through our home lab kind of publisher. We call it a publisher, kind of like a VPN concentrator. We call it a publisher. How much data was transferred, how many packets were sent, the start and end time of that transaction, the actual POP that he connected through Netskope. So even though he connected to this application in this data center, it was our London POP that serviced that connection as well. So a lot of detail around that. But of course, with that information, what we can then do, we can also start to build some quite interesting reports as well. So we can look at what kind of users are accessing what services. So I've got my users on the left-hand side here. I've got, I don't know if it's really showing through. Let me make it a little bigger if I can. Hopefully that's a little bit better. Might look a bit squashed because I'm zooming in, but we've got the user on the left-hand side within the organization. Something that actually comes back to this as well, a customer I was working with recently who is very driven by mergers and acquisitions. We talked to him about these different companies. So even though we've got different companies like Netskope, we've got TechByte as a company, we've got Swig Cloud as a company, we've actually got these different domains, but we're still able to provide that connectivity across those different sort of Active Directory users or Azure Active Directory users, or whether they're using Okta, whatever their IAM is, we can provide that access into those applications. And we can see there that they're connecting through that kind of home connection, that AWS connection, and then which actual applications they're connecting to. And we saw just in the end user demo connecting to that NAS drive. But again, as part of that discovery, we could see some of these other applications. So there's a a VMware application, there's a domain controller, there's some sort of web-based application, other domain controllers, RDP connections. So again, as part of that discovery, we could use a tool like this to understand who is connecting to what applications. And that might also uncover some behaviors that we weren't expecting, where we might see users attempting to connect to applications that might be a little bit unusual and we wouldn't expect them to connect to. We can look at kind of top users by upload and download, that traffic distribution. So most of my applications, sort of 85% of my applications that my users are connecting to seem to be in the data center, and about 15% appear to be cloud hosted. And then we can see from a application perspective as well, what are my sort of top applications. So this is sort of, I think within the last 24 hours, I've seen 17 connections to my NAS drive, and I've seen sort of 2,000 connections to my domain controller, which might not be that unusual. You know, Active Directory can be quite noisy, lots of DNS type queries that occur fairly regularly. And then sort of some of the smaller applications here as well. So now we've really got that control over what applications users are connecting to. We've got the context of who's uploading, who's downloading, what is the distribution, what are my top policies, what is the breakout of those applications. And now we can define a policy around that and really start to control and remove that lateral movement, bringing it down to those kind of zero trust principles. We go back and share, stop sharing there. We'll share back on the presentation.
Like I said, any questions, please use the Q&A bar at the top.
So yeah, really just to Q&A now, I think. Please feel welcome to ask any questions in the chat or unmute yourself if you have any questions. Also feel
to talk.
Yeah, no, that's fine. And please feel welcome again. If you have any sort of follow-up questions, you're welcome to email Chris or myself as well at the end of the session. I hope that's been an informative and kind of quick webinar on zero trust network access and zero trust principles.
Thank you, Ross. So as you mentioned, we've gone through a little bit of the principles there. We've gone through, I think, some really nice anecdotal sort of analogies of where zero trust meets the kind of modern world. The resonance with me and the airport queues with my travelling is one I can definitely recommend. So yeah, I think this is hopefully been of use to yourselves. One of the things that Ross did mention early on was the fact that this is just one of the features of the platform. So the Netskope platform is a full secure services edge and does everything from AI DLP to the ZTNA. Obviously, the ZTNA is one of the kind of key features that a lot of people are looking at the minute. But it's not a buy-all. You don't have to kind of take the entire platform. You can actually look at individual functions and features. And we can work with you to kind of help to isolate those down. And we've got a question from Sergio, which is, what would you say is the main difference from your competitors in terms of architecture, features, operational model? Ross.
So yeah, that's a great question. I think it comes back to the ZTNA Next capability. This is sort of the primary use case. As I mentioned before, one of the biggest challenges around just deploying ZTNA as a kind of a standard technology is it's very focused on client-initiated connections to servers and applications. When you layer in Netskope's SD-WAN fabric as well, we can fully replace the VPN by connecting users into that kind of SD-WAN fabric, and also becoming a resource in the network so that servers can initiate connections back to clients as well. So I'd say kind of that's the first thing. But when it comes to zero trust network access as a product in an isolated sort of way, I think the value for Netskope is really the wider platform, and actually being able to, if you start your journey with Netskope around sort of ZTNA, as you look in the future and you start to think about how do I secure users access to general internet, and that kind of shadow IT, applying DLP to uploads and downloads to things like WeTransfer or ZippyShare or OneDrive, being able to layer in DLP to your SMTP or your email gateway. We do endpoint as well, and we deliver that all through one client. So when I talk about ZTNA and I say, oh, we deliver it through one client, that in its own isolation isn't particularly interesting. But when you start saying we can do one client for web proxy, endpoint DLP, zero trust network access, SD-WAN, Fabric, and layering that in, like that's when it all really comes together. Yeah.
Yeah. And I think also, just from my perspective, I mean, you know, there are a lot of vendors out there with a ZTNA solution. What I'd also say is that the actual engine that the traffic goes through is the same engine that would go through if you were to use the SWIG or the CASB. So there are platforms out there where there are distinct different pieces to the pie. And depending on what feature you take, it will take a certain path and it will go through certain different platforms. The Netskope platform, you build the policies once in one place, and then everything goes through it, irrespective of whether you are a secure web gateway user in an office that's then using an SD-WAN client and network to get to the SSE to make a SASE architecture, or you're working from home, or you're working from a hotel or an airport. So the fundamental engine that the traffic is processed through is the same, which means the policies can then apply consistently. And I think one of the biggest things I hear from people I'm talking to in the security world is consistency is king. You know, once you've built your policies and spent a lot of time isolating and defining those, you just want everyone to be applied in a consistent fashion, so then you know that once you've got the things right at the front end, that it's basically delivered in a consistent fashion. So great question, thank you very much, Sergio. Stuart's mentioned ChatGPT. I sort of mentioned earlier, one of the new evolutions of the solution that Netskope have got is also the DLP has expanded to take into consideration AI as well. And again, that single platform, single client. So it means that there's a whole host of functionality and features that can be leveraged by by end users without having to try and build different clients, etc. There's another question here.
Yeah, about replacement for SD-WAN for Aruba 40 versus Velo. Yeah.
Both is the answer. There is a solution for SD-WAN that the Netskope platform has an in-house, as in the integrated solution, but Netskope still works perfectly well with other third-party SD-WAN providers, such as the Fortinets, the Arubas, the Versas, the Velo clouds. So it has both an internal SD-WAN function, or it has third-party SD-WAN functions it can support, and there's a lot of API integration in there in that as well.
Just to clarify on that as well, so if you're looking at Netskope for an SSE connectivity, so that kind of web access, web steering, you talked about things like OpenAI and DLP and threat protection to the internet, fully supported third-party Azure, Aruba 40, we can connect those SD-WANs into the SSE fabric. But just a clarification point on the SD-WAN point, if you want to use ZTNA Next, then it would require Netskope's SD-WAN just for the ZTNA Next part.
Yeah, which is primarily probably around the server-initiated communications.
For the server-initiated communications, yeah, that's right. But if you were just going to do ZTNA for client-initiated, like, to be honest, that's like 95%, in some cases 100% of connectivity. If you're just looking at SSE, which is like basically ZTNA and like web filtering, then you can continue using your existing SD-WAN. It's only for the ZTNA Next part, the server-initiated connections, that you would be looking to leverage Netskope's SD-WAN solution. And just as one point, when you mentioned Velo Cloud, one of the founders of Velo Cloud is with Netskope, and they've kind of used a lot of the lessons that they learned in building Velo over with now Netskope. And so the SD-WAN that we have is actually run by one of the founding fathers of Velo Cloud. So a lot of knowledge and experience around our SD-WAN offering.
So in summary, if you'd like to know or learn a bit more about the Netskope ZTNA solution, we'd be more than happy to kind of work with you to build either some proof of value, some proof of concept. We can do some more in-depth demonstrations around some of the more detailed functionality and features. And then there's also we can do some consulting around what the art of the possible is and where your existing solution could map into a next generation ZTNA solution. So hopefully this has been useful. I'm really appreciative of the fact that there's an awful lot of information that we try and put across on these. We try and do it deliberately to add some value, but appreciate it. You've taken time out of your days to join this. So thank you very, very much for joining this. We will get the slides that we've gone through today across to everyone who's registered. If anyone has any questions, please reach out. Yeah, it's been good to have you all here today, and thank you very much for attending.
Thanks, everyone. Take care. Have a good day. Bye-bye.